tabletop shake table setup can be used to demonstrate and investigate the effect of sinusoidal, vibrational, and seismic movements for different materials and scale models. When calibrated correctly, the shake table can simulate scale positional data of various acceleration curves in a very accurate manner. It can also be set up to test longitudinal and transverse motion. Opening the Shake Table 2 folder, select the LabVIEW folder and then Operation Files. Navigate to Run Sine Wave for the Q8 USB DAC and wait for LabVIEW to open and load all relevant project and header files. This may take a while. Once open, you can choose whether or not you want position and acceleration data to be logged to a waveform file. This can be opened in Excel later for further analysis. If you choose to log data, specify the name of the waveform file in addition to the data logging duration. And ensure that Save to Data File is checked off. To specify oscillation parameters before starting the simulation, you can enter the desired amplitude and frequency in the indicated boxes. To begin the simulation, select Run and observe that a voltage is being applied and that motion of the table is oscillating back and forth. You can adjust the frequency by turning the dial. Ensure that you do not push the frequency over 3 Hz if the table is not properly secured to the ground. You can also adjust the amplitude by using the slider. Once done, press the stop button to halt the test. Open the Shake Table 2 folder and select LabVIEW and then Operation Files. Navigate to Run Sine Sweep for the Q8 USB DAC and wait for LabVIEW to open and load all relevant project and header files. This may take a while. Once open, you can again choose if you want to log data in a waveform file. Again, change the name of the file and ensure that Save to Data File is checked off. For the sweep, specify the fixed amplitude in addition to the duration of the sweep and the frequency range that you wish to cover. Select Run to begin and allow the simulation to run to the target frequency, after which the program will halt itself. Start by opening the Shake Table 2 folder. Open LabVIEW and then Operation Files. Navigate to Generate Sine Wave and wait for LabVIEW to load up. Specify the name of the custom sine wave. And then enter the relevant amplitude and frequencies for each term in the compound sine wave equation that is to be modeled. You can also adjust the maximum displacement, duration, and sampling interval of the waveform. Once done, select Run to generate the waveform, which is displayed on the plot. Navigating to the Operation Files directory, you can now see that the newly created sine wave is available for later use. Start by opening the web browser and navigating to the Pure Ground Motion database, or any other database of your choice. In this case, the link is shown above. Next, sign up or log into the database. For the Pure database, you can select earthquakes by region as shown. LabVIEW will scale the data appropriately for the table, so no scaling is required. You can specify various parameters to filter the results, or simply search through all the records that are available. Scrolling down, you can see a list of all the different earthquakes in the database with the different metrics and parameters listed at the top. There are also different types of acceleration files available for any given earthquake. You can also search through the earthquakes using the map feature below. To download the data, select Download Time Series Records, after which a zip file will be created where all the files will be stored. Here I've already extracted all the files into a folder, which includes an Excel document of all the different earthquakes and their metrics. For LabVIEW, you need to use the .at2 file for a given earthquake. This needs to be copied into the working directory of the shake table. Which in this case is the earthquake data files folder in the Operation Files directory. Next, select Generate Earthquake and wait for LabVIEW to load. Once open, you will have to run the program before the earthquake list is updated in order to see the new earthquake records that were added. Once you see the desired earthquake acceleration profile, select it and modify the max displacement as well as the file name. And ensure that the displacement does not exceed 7.6 centimeters. Press Scale Earthquake and the scaled position and acceleration profiles will be generated, which can now be used for later use. You should also see the new waveform file in the Operation Files directory, which will be used when simulating the earthquake. Open the Shake Table 2 folder and select LabVIEW, and then select Operation Files. Navigate to Run Earthquake for the Q8 USB DAC, and wait for LabVIEW to load and open all the relevant project and header files. This may take a while. Once opened, you will notice that the new waveform files are not available. So, you must run and stop the program very briefly to update the list in order to simulate the new earthquake file that you wish to proceed with. Now you should be able to see the new waveform files available. Select the desired earthquake or compound sine wave file that you want to simulate, and also rename the waveform file if you wish to log the position and acceleration data, and ensure that the Save to Data file is checked off. Select Run, after which the simulation will run until all the position data has been run through. Or until the user presses the stop button.